guys, welcome to my channel. First of all, let me introduce myself. My name is Melisha Frianti, and here I'm going to present my presentation about equilibrium and exchange to fulfill my course assignment, which is macroeconomic theory. Well guys, I'm a little bit nervous that this is my first video using English, but I'm not going to tell you about what I'm feeling right now because I just want to practice my English for getting better, so I hope it's not getting worse, and let's get into it. Enjoy! Before undertaking the study in detail, it seems worthwhile at this point to give some example of equilibrium analysis, how the prices adjust so as to make the demand and supply decision of economic agents compatible. In order to do so, we will have to briefly consider the other side of the market, the supply side. 1. Supply. We have already seen a few examples of supply curves. We considered situation where consumers would choose to be net suppliers or demanders of goods that they owned, and we analyzed labor supply decisions. In all of these cases, supply curve simply measure how much the consumer was willing to supply of a good at each possible market price. Indeed, this is the definition of the supply curve. For each P, we determine how much of the good will be supplied. In the next few chapters, we will discuss the supply behavior of firms. However, for many purposes, it's not really necessary to know where the supply curve or the demand curve comes from in the terms of the optimizing behavior that generates the curves. For many problems, the fact that there is a functional relationship between the price and the quantity that consumers want to demand or supply at the price is enough to highlight important insights. 2. Market equilibrium. Suppose that we have a number of consumers of a good. Given their individual demand curves, we can add them up to get a market demand curve. Similarly, if we have a number of independent suppliers of this good, we can add up their individual supply curves to get a market supply curve. The individual demanders and suppliers are assumed to take prices as given outside their control and simply determine their best response given those market prices. A market where each economic agents take the market prices outside of their control is called a competitive market. The usual justification for the competitive market assumption is that each consumer or producer is a small part of the market as a whole and thus has a negligible effect on the market price. For example, each supplier of wheat takes the market price to be more or less independent of his actions when he determines how much wheat he wants to produce and supply to the market. Although the market price may be independent in any one agent's action in a competitive market, it is the actions of the agents together that determine the market price. The equilibrium price of the good is that price where the supply of the goods equals the demands. Geometrically, this is the price where the demand and the supply curves cross. 3. Two special cases. There are two special cases of market equilibrium that are worth mentioning since they come up fairly often. The first is the case of fixed supply. Here the amount supply is given number and is independent of price. That is, the supply curves is vertical. In this case, the equilibrium quantity is determined entirely by supply conditions and the equilibrium price is determined entirely by demand conditions. The opposite case is the case where the supply curve is completely horizontal. If an industry has a perfectly horizontal supply curves, it means that the industry will supply any amount of a good at a constant price. In this situation, the equilibrium price is determined by supply conditions, while the equilibrium quantity is determined by the demand curve. Two cases are depicted in figure 16.1. In these two special cases, the determination of a price and the quantity can be separated, but In the general case, the equilibrium price and the equilibrium quantity are jointly determined by the demand and supply curves. As you can see, special cases of equilibrium. Case A shows a vertical supply curve where the equilibrium price is determined solely by the demand curve. Case B depicts a horizontal supply curve where the equilibrium price is determined solely by the supply curve. 4. Inverse demand and supply curves. Example, equilibrium with linear curves. Suppose that both the demand and the supply curves are linear, which is dP is A minus BP, as P is C plus dP. The coefficient A, B, C, D are the parameters that determine in the intercepts and slopes of these linear curves. The equilibrium price can be found by solving the following equation. dP is A minus BP is C plus dP is also SP. The answer is P action is A minus C divided D plus B. The equilibrium quantity demand and supply is dP action is A minus BP action is A minus B multiply A minus C divided B plus D is AD plus BC divided B plus D. We can also solve this problem by using the inverse demand and supply curves. First, we need to find the inverse demand curve. At what prices some quantity Q demanded. Simply substitute Q for dP and solve for P. We have Q is A minus BP, so PdQ is A minus Q divided B. In the same manner, we find PSQ is Q minus C divided D. Setting the demand price equal to the supply price and solving for the equilibrium quantity, we have PdQ is A minus Q divided B is Q minus C divided D is PSQ. Q accent is AD plus BC divided B plus D. Note that this gives the same answer as in the original problem for both the equilibrium price and the equilibrium quantity. 5. Competitive statics. Example, shifting both curves. Situation is considered a competitive market for apartments described in Chapter 1. Let the equilibrium price in the market be P accent and the equilibrium quantity be Q accent. Suppose that the developer converts M of the apartments to condominiums which are bought by the people who are currently living in the apartments. What happens to the equilibrium price? The answer is the situation is depicted in the figure 16.2. The demand and the supply curves both shift to the left by the same amount. Hence, the price is unchanged and the quantity sold simply drops by M. Algebraically, the new equilibrium price is determined by dP minus M is SP minus M, which clearly has the same solution as the original demand equals supply condition. As you can see the picture shifting both curves, both demand and supply curves shift to the left by the same amount, which implies the equilibrium price will remain unchanged. 6. Taxes. Describing a market before and after taxes are imposed present a very nice exercise in comparative statics, as well as being of considerable interest in the conduct of economic policy. Let us see how it is done. The fundamental thing to understand about taxes is that when a tax is present in a market, there are two prices of interest: the price the demander pays and the price the suppliers get. These two prices is the demand price and the supplier price differ by the amount of the tax. There are several different kinds of taxes that one might impose. To example, we will consider here are quantity taxes and the value taxes, also called ad valorem taxes. As you can see in the picture, the imposition of a tax. In order to study the impact of a tax, we can either shift the demand curve down, as in the panel A, or shift the supply curve up, as in panel B. The equilibrium price paid by the demanders and received by suppliers will be the same either way. And PD is PS plus T. Substituting from the second equation into the first, we have A minus B multiply PS plus T is C plus DPS. Solving for the equilibrium supply price, PS accent plus T is P accent D is A minus C minus BT divided D plus B plus T is AC plus DT divided D plus D. Note that the price paid by the demander increases and the price received by the suppliers decreases. The amount of the price change depends on the slope of the demand and the supply curves. As you can see in the picture, another way to determine the impact of a tax, slide the line segment along the supply curve until it hits the demand curve. And now the last but not least summary of this lesson is the supply curve measure how much people will be willing to supply of some good at each price. The two, an equilibrium price is one where the quantity that people are willing to supply equals the quantity that people are willing to demand. 3. The study of how the equilibrium price and the quantity change when the underlying demand and supply curves changing is another example of comparative statistics. 4. When a good is taxed, there will always be two prices, the price paid by the demanders and the price received by suppliers. The difference between the two represent the amount of the tax. How much a tax gets passed along to consumers depends on the relative steepness of the demand and the supply curves. If the supply curve is horizontal, all of the tax gets passed along the consumers. If the supply curve is vertical, none of the tax gets passed along. 6. The deadweight loss of a tax is the net loss in consumers, surplus plus producers. Surplus that arises from imposing the tax. It measures the value of the output that is not sold due to the presence of the tax. 7. A situation is Pareto efficient is there is no way to make some group of people better off without making some other group worse off. 8. The Pareto efficient amount of the output to supply in a single market is that amount demand and the supply curves cross, since this is the only point where the amount that demanders are willing to pay for an extra unit of output equals the price at which suppliers are willing to supply an extra unit of output. Okay, now let's get into it to the next lesson, which is exchange. In this chapter, we will begin our study of general equilibrium analysis, how demand and supply conditions interact in several markets to determine the prices of many goods. As you might suspect, this is a complex problem, and we will have to adopt several simplifications in order to deal with it. First, we will limit our discuss to the behavior of the competitive market so that each consumer and producer will take prices as given and optimize accordingly. The study of general equilibrium with imperfect competition is very interesting but too difficult to examine at this point. Secondly, we will adopt our usual simplifying assumption of looking at the smallest number of goods and consumers we possibly can. In this case, it turns out that many interesting phenomena can be depicted using only two goods and two consumers. All of these aspects of general equilibrium analysis that we will discuss can be generalized to arbitrary numbers of consumers and goods, but the exposition is simpler with two of each. Third, we will look at the general equilibrium problem in two stages. We will start with economy, where people can fix endowment of goods and examine how they might trade these goods among themselves. No production will involved. This case is naturally known as the case of pure exchange. Once we have a clear understanding of pure exchange markets, we will examine the production behavior in the general equilibrium model. 1. The Edgeworth box. There is a convenient graphical tool known as the Edgeworth box that can be used to analyze the exchange of two goods between two people. The Edgeworth box allows us to depict the endowments and the preferences of two individuals in one convenient diagram, which can be used to study various outcomes of the trading process. In order to understand the construction of an Edgeworth box, it is necessary to examine the indifference curves and the endowments of the people involved. The Edgeworth box, shown in figure below, can be used to illustrate these concepts graphically. We first use a standard consumer theory diagram to illustrate the endowment and the preference of the consumer A. We can also mark off on this axis the total amount of each good in the economy, the amount that A has plus the amount that B has of each good. Since we have only interest in visible allocation of goods between the two consumers, we can draw a box that contains the set of the possible bundles of the two goods that A can hold. As you can see in the picture, an Edgeworth box, the width of the box measures the total amount of good 1 in the economy, and the height measures the total amount of good 2. Person A's consumption choices are measured from the lower left-hand corner, while person B's choices are measured from the upper right. 2. Trade. Now that we have both sets of preferences and endowments depicted, we can begin to analyze the question of how trade takes place. We start at the original endowment of goods denoted by point W in the last figure. Consider the indifference curves of A and B that pass through this allocation. The region where A is better off than at her endowment consists all of the bundles above her indifference curve through W. The region where B is better off than at this endowment consists all of the allocation that are above. From his point of view, his indifference curve through W. Where is the region of the box where A and B were both made better off? Clearly, it is in the intersection of these two regions. This is the lens-shaped region illustrated in figure 1. Presumably, in the course of their negotiation of two people involved will find some mutually advantageous trade. Some trade that will move them to this some point inside the lens-shaped are such area at the point M. Now we can repeat the same analysis at the point M. We can draw the two indifference curve through M, construct a new land-shaped region of mutual advantage, and imagine the traders moving to some new point N in this region. So it goes, the trade will continue until there are no more trades that are preferred by both parties. What does such a position look like? 3 Pareto efficient allocations. The answer is given in the figure. 3 Pareto efficient allocation. The answer is given in the figure. At this point M in this diagram, the set of points above A's indifference curve doesn't intersect the set of points above B's indifference curve. The region where A is made better off is disjoint from the region where B is made better off. This means that any movement that makes one the parties better off necessarily makes the other party worse off. Thus, there are no exchanges that are advantageous for both parties. There are no mutually improving trades at such an allocation. An allocation such as this known as a Pareto efficient allocation. This idea of Pareto efficiency is a very important concept in economics that arises in various guises. As you can see in the picture, a Pareto efficient allocation. At a Pareto efficient allocation such as M, each person is on his highest possible indifference curve, given the indifference curve of the other person. The line connecting such points is known as contract curve. A Pareto efficient allocation can be described as an allocation where 1. There is no way to make all the people involved better off, or there is no way to make some individual better off without making someone else worse off, or all of the gains from the trade have been exhausted, or there are no mutually advantageous trades to be made, and so on. Indeed, we have mentioned the concept of Pareto efficiency several times already in the context of a single market. We spoke of the Pareto efficient level of output in the single market as being the amount of output where the marginal willingness to buy equaled by the marginal willingness to sell. At any level of output where these two numbers differ, there would be a way to make both sides of the market better off by carrying out a trade. In this chapter, we will examine more deeply the idea of Pareto efficiency involving many goods and many traders. The set of all Pareto efficient points in the Edgeworth box is known as the Pareto set or contract curve. The latter name comes from otherwise they wouldn't be final because there would be some improvement that could be made. The Pareto set describes all the possible outcomes of mutually advantageous trade from starting anywhere in the box. If we are given the starting point, the initial endowments for each consumer, we can look at the subset of the Pareto set that each consumer prefer to his initial endowment. Depicted in the figure, the allocation in this land-shaped region are the possible outcomes of mutual trade starting from the particular initial endowment depicted in the diagram. But the Pareto set itself doesn't depend on the initial endowment except insofar as the endowment determines the total amounts of both goods that are available and thereby determines the dimensions of the box. 4. Market trade. The equilibrium of the trading process described above, the set of Pareto efficient allocation, is very important, but it still leaves a lot of ambiguity about where the gains end up. The reason is that the trading process we have described is very general. Essentially, we have only assumed that the two parties will move to some location where they are both made better off. If we have a particular trading process, we will have a more precise description of equilibrium. Let's try to describe the trading process that mimics the outcome of a competitive market. Suppose that we have a third party who is willing to act as an auctioneers for the two agents and a B. The auctioneers chooses a price for good 1 and a price for good 2 and present these prices to the agents A and B. Each agent then sees how much his or her endowment is worth at the prices and decides how much of each good he or she would want to buy at those prices. As we can see in the picture, gross demands and net demands. Gross demands are the amounts the person wants to consume. Net demands are the amounts that the person wants to purchase. 5. The algebra of equilibrium. These equations say that in equilibrium, the total demand for each good should be equal to the total supply. As you can see in the picture, equilibrium in the edgeward box. In equilibrium, each person is choosing the most preferred bundle of his budget set, and the choices exhaust the available supply. There is another way to describe the equilibrium to rearrange these two equations to get. Six, Walras law. Using the notation established above, Walras law states that the value of aggregate excess demand is identically zero. To say that the value of aggregate demand is identically zero means that it is zero for all possible choices of prices, not just equilibrium prices. 7. Relative prices. As we've seen above, Walras law implies that there are only K1 independent equations in a K-good general equilibrium model. If demand equals supply in K1 markets, demand must equal supply in the vinyl market. But if there are K goods, there will be K prices to be determined. How can you solve these K prices only K1 equations? The answer is that there are really only K1 independent prices. We saw in chapter 2 that we multiplied all prices and income by a positive number f. Then the budget set wouldn't change, and thus the demanded bundle wouldn't change either. In the general equilibrium model, each consumer's income is just the value of his or her endowment at the market prices. If we multiply all price by T, we will automatically multiply each consumer income by T. The requirement that demand equals supply in every market can only be expected to determine the equilibrium, the relative prices, since multiplying all prices by a positive number will not change anybody's demand and supply behavior. Well guys, that's all the explanation about equilibrium and exchange from me. I know I have a lot of mistakes in this video, but I hope you guys can enjoy this video. I'm sorry for the mistakes. Thank you for watching, and Assalamualaikum warahmatullahi wabarakatuh. Yo, chick.
Put that on that beat, yo.
If your chick come close to me, she ain't going home when she supposed to be. I'm getting money like I'm supposed to be. I'm getting money like I'm supposed to be. Oh, all my niggas close to me, and all the mother niggas where they supposed to be. Oh, the hoes go for me. How your chicks in the pic like post for me. Oh, that's how I supposed to be.